Dear students, in the last class, we have studied about ionic bonding. Today, let us study the covalent bond and the various theories associated with the covalent bond. The first theory was proposed by Lewis, hence it is known as Lewis concept of covalent bond. G. N. Lewis in 1916 proposed the concept of covalent bond. It is more broad-based and is present in large number of molecules. This bond is present in the atoms of nonmetals. The bond formed by mutual sharing of an electron pair is called covalent bond. Covalent bond is found between the two atoms of comparable electronegativities. Both the atoms share one electron each to form electron pair to achieve noble gas configuration. Covalent bond is represented by placing a line between the bonded atoms. Compounds containing covalent bond are called covalent compounds. The atoms taking part in the covalent bond formation may share 1, 2 or 3 electron pairs depending upon their requirement. This leads to the formation of single, double or triple bond between the two atoms. So, it is known that maximum 3 bonds are present between the two atoms. Let us take some of the examples of a simple covalent molecules like hydrogen molecule, which is formed by sharing one unpaired electron each from the two hydrogen atoms. Another example is the chlorine molecule, which contains the 7 electrons in the valence shell, and these 7 electrons out of the 7, 3 are paired and 1 is unpaired. The unpaired electron shares with another chlorine and both the atoms attains octet rule. Similarly, the oxygen molecule having 2 unpaired electrons shares with another oxygen molecule forming another oxygen atom forming oxygen molecule, wherein both oxygen atoms attains octet. The similar way, the nitrogen contains the 3 unpaired electrons. So these 3 unpaired electrons shares with another nitrogen atom to form a nitrogen molecule where both the nitrogen atoms have 1 lone pair of electron. Covalent bond present between the two atoms of the same element is called non-polar covalent bond. It is found in homoatomic molecules like hydrogen, chlorine, oxygen, nitrogen, etc. Covalent bond present between the two atoms of different elements is called polar covalent bond. It is found in heteroatomic molecules like HCl, H2O, CH4, NH3 and so on. The polar character results partial ionic character between the two atoms due to the higher electronegativity differences. This leads to the dipole moment between the two atoms. The structure of covalent molecules or ions in which the shared electrons are represented by dots are known as Lewis structures, and indicated by lines are called Cooper structures. Below I have shown both the structures of the Lewis and Cooper for oxygen and ammonium ion. So this is a slide that shows how a covalent bond is formed between the two atoms by sharing the two unpaired electrons, so that both the atoms attains octet structure. So this is the another slide showing the formation of chlorine molecule, oxygen molecule, nitrogen molecule and HCl molecule. So this slide shows between the two atoms how a single bond, double bond and a triple bond results. So I have shown the diagram of hydrogen molecule chlorine H2OCH4 CCl4 where between the two atoms you have a single bond. Then we have carbon dioxide, we have oxygen, we have ethene. There between the two atoms we have double bond. And in case of the nitrogen and ethane, between the two atoms we come across the triple bond. And what would be the structure of these molecules? This slide shows the polar and non-polar bonds. So non-polar bond is formed by equal sharing of electrons and it is found in between the two atoms of the same element. Polar covalent bond is formed by unequal sharing of electrons which is found between the two atoms of two different elements where one of the element is more electronegative than the other. So this slide also shows about the polar and non-polar covalent bonds. So this is also the slide shows the electronegativity between the covalent and ionic. So the covalent bond is having the equal sharing, it is called non-polar covalent bond. So if the covalent bond is found between the two atoms of different elements, then it leads to the polar character, and if the electronegativity difference is too much, it leads to the ionic bond formation. So therefore, ionic character increases from non-polar covalent bond to polar covalent bond and then further to ionic bond. Number of covalent bonds attached to the central atom in a molecule is called covalency. It is 1 in case of hydrogen chlorine HCl, 2 in case of oxygen and 3 in case of nitrogen and 4 in case of a methane molecule. Let us study about the factors favoring the formation of covalent bond. The covalent bond results only when the following conditions gets satisfied. Number 1, the atoms having high ionization energy always results covalent bond. Covalent bond is formed between the two atoms having almost equal electron affinities. High nuclear charge and small internuclear distance favors the formation of covalent bond. Atoms having 5, 6 or 7 electrons in their valence shell involves in covalent bond formation. Atoms with equal electronegativities result covalent bond. Let us study the properties of covalent compounds. Covalent compounds consist of discrete molecules so that force of attraction between adjacent molecule is weak. Due to this covalent compound may be gases, liquids or even soft solids. Example, chlorine is a gas, bromine is a liquid and iodine is a solid. The crystals of covalent solids are of two types, namely the joint molecules, example diamond, silicon carbide, aluminium nitride, etc. and layer lattices like graphite, cadmium iodide, boron nitride, etc. Joint molecules have high melting and boiling point, while layer lattices have low melting and boiling point. Joint molecules are poor conductors of heat and electricity, while layer lattices are good conductors of heat and electricity. Giant molecules are soluble in non-polar solvents like benzene, carbon tetrachloride, etc., while layer lattices are soluble in polar solvents like water, alcohol, etc. Covalent compounds are neither hard nor brittle because of weak forces holding the molecules in solid state. Covalent compounds undergo molecular reactions in solutions. These reactions are slow reactions, hence need a control of temperature and pressure. Since covalent bonds are rigid and directional, they can give rise to different arrangements of atoms in space. Hence, covalent compounds exhibit isomerism. Failure of octet rule in covalent compounds. There are many molecules. They have less than 8 electrons as well as more than 8 electrons. As far as the Lewis theory is concerned, atoms tries to contain 8 electrons in the valence shell to attain stability. So in contrast to this, this is an explanation. There are many covalent molecules in which the central atom has electrons either less than 8 or more than 8 in its outermost shell. Let us take an example, beryllium chloride. In beryllium chloride, beryllium atom is attached to the two chlorine atoms through the two covalent bonds. Each covalent bond gives 2 electrons. So therefore, beryllium chloride is a stable molecule where beryllium contains only 4 electrons. But still it is stable. Similarly, boron trifluoride, so where boron atom is attached to the 3 fluorine atoms through a covalent bond, each covalent bond gives 2 electrons, so therefore 6 electrons are there on the boron trifluoride. Similarly, the nitric oxide, where the nitrogen is attached to the oxygen through 2 covalent bonds, so therefore 4 electrons, 1 lone pair of electrons, 6 electrons, and 1 unpaired electron, 7 electron. So in nitric oxide, nitrogen atom contains 7 electrons. Octet remains incomplete in these molecules. Here I have shown some of the properties of the covalent compounds, which we have already discussed. So the electrons are shared, only non-metals present in covalent compounds, low melting point these have, and also the boiling point. These covalent compounds normally gases and liquids or even solids at room temperature. They don't conduct electricity. Normally they don't dissolve in water. The larger the molecules, the greater the chance it will be a solid at room temperature. Mode of neutral nonmetals and localized shared electrons. So this is also the another table which shows the properties difference between the covalent bonds and ionic bonds. Students, you go through the various properties which gives a comparative study between the covalent bond and the ionic bond. Now let us take some of the molecules wherein the octet is expanded. For example, phosphorus pentachloride. In phosphorus pentachloride, phosphorus is linked to the 5 chlorine atoms through 5 bonds. So each bond contributes 2 electrons. So therefore, on the phosphorus, we have 10 electrons. Similarly, sulfur hexafluoride, on the sulfur we have 12 electrons because the sulfur is connected to 6 covalent bonds. If I take chlorine trifluoride, in chlorine trifluoride we have the chlorine is connected to 3 fluorine atoms through a 3 covalent bonds. So 3 into 2 is 6 electrons. Chlorine contains the 2 lone pairs of electrons. So therefore it contains 10 electrons. In another molecule like iodine heptafluoride IF7, where iodine atom contains 14 electrons. So all such things makes the Lewis theory to have some drawbacks. So let us know what are the failures of the Lewis theory. Lewis theory fails to explain the structure of covalent molecules of insufficient octet and superoctet structures. It cannot explain the cause of covalent bond formation, nature of attraction, attractive forces in covalent bond, and why different amounts of energy are released during the formation of different molecules. It cannot predict the geometry of the molecules. Let us take these failures, how we can explain. That is explanation of the failure of octet rule. So major one is this. So to explain the failure of the octet rule, Sugden's concept of single linkage is taken into the account. So what is this? Sugden postulated that the central atom of the molecules like PCl5, sulfur hexafluoride, etc. maintains its octet by forming single electron bonds with some of the combining atoms and normal 2 electron covalent bonds with other atoms. Single electron bond is represented as a half arrow with its head pointing from the donor towards the acceptor. Let us take an example of the PCl5. In case of PCl5, we have 3 covalent bonds, have 2 electrons between the two, and we have two the covalent bonds where only 1 electron is present, which is shown by half arrow mark. So that's why the PCl5 in general, when it is treated with other, immediately decomposes to PCl3 and Cl2 because of single electron bond in case of PCl5. So that gives the 8 electron concept in PCl5. Similarly, in sulfur hexafluoride, so we have the 4 single electron bond between sulfur and fluorine and the 2 electron bond between sulfur and fluorine. So this is how the Sugden explains the octet in these molecules. Another theory was put forwarded by Sidgwick, and it is also called the Sidgwick's concept of maximum covalency. According to this concept, it is not necessary for an element to have maximum covalency of 4. That is, it is not essential that an element be surrounded by 8 electrons for its stability. The maximum covalency of an element depends upon the period in which the element is present. For first period, n is equal to 2, covalency is 1, therefore the number of electrons is 2. For second period, n is equal to 2, maximum covalency is 4. Therefore, the number of electrons in these elements, it can occupy up to 12 electrons. For a period of 3 and 4, the maximum covalency is 6 and 8, so that it can take the 12 and 16 electrons. Hence, there is no anomaly in the compounds like PCl5, SF6, ClF3, IF7 and so on. So this is how the Sedgwick explained the maximum covalency. Dear students, you learn up to this much in the class, and in the next class let us study in detail about the ionic character in covalent compounds. Thank you.